Hello everyone. Today I'll be presenting the paper RECL, Responsive Resource Efficient Continuous Learning for Video Analytics. The work appeared in NSDI 2023 and was authored by researchers from MIT, Microsoft, and the University of Chicago. So let's start with the background. Video analytics is becoming essential in the current world for things like traffic management, security, etc. But running deep neural network on the edge is very expensive. For example, the paper mentions that running a high-end NVIDIA V100 GPU can only support about two video streams running a large model like YOLO V5 at 30 frames per second. So this computation cost makes it difficult to scale uh, to hundreds of cameras. So to solve this cost problem, a common approach is to use special or expert DNN models. So instead of running a massive model all the time, we use a technique called knowledge distillation. So the idea is that we take a large teacher model to label data and train a smaller compressed student model that is specialized for a specific scene. And the student model is much faster and cheaper to run. But specialized models have a major weakness, which is data drift. So because the student model is small, it overfits the current scene. So like if the weather changes or um, like the car moves to a new street, the accuracy drops, right? So to fix this, systems like IKEA introduce continuous retraining. So this means we constantly retrain the student model on the edge to keep up with changing video stream. The related works, let's skip this part. Okay. So there are some problems with continuous retraining system. So limitation one is high cost. Retraining consumes 70 to 90% of the GPU resources on the edge. As you can see here, um, as you increase the number of cameras from 2 to 8, the accuracy or the map score of retraining um, drops significantly because the GPU is overwhelmed and can't retrain fast enough for everyone. The limitation two is response time. So retraining takes time. So for example, if you look at these images, imagine like a car um, entering a tunnel. So the scene changes instantly from bright to dark. So continuous retraining takes time to collect frames and train a new model. So here in the graph, um, you can see the response time gap. The accuracy drops drastically and stays low for nearly a minute until the retraining finishes. And this is not acceptable for real-time analytics. So the third limitation concerns existing attempts to fix this via model reuse. Systems like Odin try to reuse historical models to avoid retraining. However, they use complex autoencoders, which are not designed for efficiency, especially resource efficiency. They often fail to find the best model quickly enough in a resource-constrained edge environment. This brings us to opportunity. So if you look at the purple line here, um, it's the ideal model reuse. So we see that if we could perfectly pick a historical model that matches the current scene, then we could maintain high accuracy even with many cameras. The pink line here, so That shows combining reuse plus retraining, which gives the best performance. So it's higher than all of the others. This suggests that since video scenes often repeat, like a car driving down the same street, we should reuse old models whenever possible to save resources. So there are some challenges, especially there are two main challenges that the paper talks about. The first one is fast selection. So how do we quickly and accurately find a specific expert model from history that fits the current video segment? And the second one is about scalability. So as the history grows, the cost of searching through thousands of model increases, and we need to reduce this search cost. Um, so this is the model design. So the design of RECL, and it has three main components. The first one it's called the model zoo, which is a collection of expert models shared across all edge devices. The second one is the model selector, which is a fast online procedure to select the best expert. And the third one is the dynamic scheduler, which is an algorithm that optimizes how GPU resources are allocated for retraining. Mm. So this is the architecture. So the edge devices, they send sample frames to the controller. And the model selector quickly scans the here it scans the model zoo and picks the top K most likely expert. A safety checker compares these expert against the current model, and the teacher labelers ground truth. So here, and we deploy the model immediately, and at the same time, the training scheduler decides if we need to retrain a new model based on the accuracy gap. So this is the GPU sharing algorithm. So for the retraining part, RECL uses a smart GPU sharing algorithm. So instead of simple round robin or first come first serve approach, RACL breaks training into micro windows. It calculates the gain for each request and prioritizes the job that will yield the highest accuracy boost per second of GPU time. This ensures resources are spent on the camera that need it the most. This slide is about updating the model zoo. So RECL performs three main tasks for this. The first is admission. So it only adds a new expert to the zoo if it significantly outperforms existing models. The second is update. So it incrementally updates the gating network to recognize this new expert. And the third is pruning. So it removes models that haven't been used for a long time to keep the search very fast. So for implementation, they built the system using PyTorch and Python, and they also use TensorRT and half precision to speed up inference. So this is the setup for the experiment. So RECL was evaluated using a dataset of 151 driving videos from YouTube. So this totaled about 71 hours of driving footage. Two tasks were tested, so object detection and image classification. And then RECL was also compared against no adaptation, AMS, EKIA, and Odin. So these are the end-to-end performance. Here, if you look at the yellow line for object detection, RECL consistently performs much better. It gets a lot more higher map score than others. I think it was about 9% higher in the paper, and also for image classification, it is much better. This slide is about the model selector evaluation. So here in the left graph, you can see the selection accuracy of RECL increases over time as the model zoo grows and learns more scene, and it performs much better than Odin. Here on the right graph, the switch rate shows that as the system runs, it relies more on reusing models from the zoo rather than retraining new ones. So this one, it's comparing the GPU scheduler. So the green bar here represents the RECL's in-band profiling. It achieves higher map score than IKEA's out-of-band profiling and AMS's round robin. So here on the right graph, we can also see that RECL has a very low profiling overhead compared to IKEA. So this one is about pruning the model zoo. So the green line here shows that with pruning, we can drastically reduce the zoo size without hurting the MAP scores, and this keeps the system efficient over long periods. This is about the model selector's top K parameter. So we can see here um, that selecting the top 10 models gives the best balance between accuracy and computational cost. And yeah, so in conclusion, RECL makes two major contributions. The first one is that it is the first end-to-end system integrating model reuse with model retraining for video analytics. And the second one is that it achieves significantly better resource efficiency and accuracy than others like IKEA and Odin. And that was it. Thank you.